Good morning, everybody. Today we will discuss about a new project about diffusion models. So in Google Scholar, we have knowing that diffusion model is very famous in nowadays. Many AI-related Google and main companies nowadays using their famous models are created under the principle of diffusion models. So today we will discuss about a small project about how diffusion model working, what is the mechanism behind it, what are the main properties of this model, how these images created under diffusion models. So a basic project we will discuss today. So in this image, you can see that it is a MRI image of brain tumor detection. So you can see that in this picture, one MRI image I am given here. It is an original image. You seen that it is a brain tumor image. But in this image, there is no brain tumor. So brain tumor means in this image, some area, some round is there. It is a significance of brain tumor. But here, this is a non-brain tumor image. So this like one image is given, that image applying some noise, then each section more noise is adding, then last that noise is full noise come under in that image. Okay, so this third image is denoised. Denoised means more noise added. So this process is over. That image have full noise added and that image is full covered with the noise. Then that process is called forward process. Then same reverse process from the noisy image, we reverse process doing. From the noisy image, uh, we try to collect the features one by one. Then some noise reduced, more noise reduced, then original image getting a pure image with the correct classification what inside it. So that type of one mechanism is called diffusion models. Diffusion models, its main meaning is a diffusion. It is a physics related thing, something diffusing into water. Some one color is diffusing into a water. Then what is happening in that red color is diffused in a water means slowly red color solved in the water. So last what happening that water full of red color. So that like a same principle is applying here also in AI. We will in image processing we will adding noise. That noise 25% adding, 50% adding, 100% adding, then full noise is everywhere. After that we try to add some features. In that from the features we retrieve noise one by one stage, then last we will get a good clarity image with the features. So that process is called diffusion. Noise adding, then noise reducing. These like diffusion models are working. So in this diffusion models, main two process is there. One is forward process and another one is a reverse process. So in forward process, what doing is we will adding small amount of noise one by one in each stage. Different stages we will adding noises. In last stage, it is a pure noise image only. So in reverse process, what doing is UNet like many models are there. UNet like any neural network using with the help of this model, we will clean the image. So here we are using brain tumor image. So brain tumor classification feature map is there. Based on that MRI image feature map, we have some tumor features are there. From this main tumor features, extract from this noise one by one or stage wise, then we will get a good quality noise free image. So this like process, this diffusion model is working. So original image, adding noise, then denoising. Again, we will retrieve noise from here. Then we getting the original image. So here in this project, I am using brain tumor detection using diffusion models. So brain tumor detection means it is using data set is MRI image. So in that MRI image, non-tumor images are there, then tumor images are there. So first we will using UNet architecture. Based on UNet neural network architecture, we using forward pass and backward pass. We will train the model using this UNet. Then we will check testing is there. In that testing, we will check that each image is working properly or not. So it working perfectly. That is the project explained one line. So I am using here Google Colab is using for all these processes because Google Colab is very good tool for processing machine learning related libraries. You can use Google Colab or Notebook for the same project. Both are working fine. But Google Colab is an online cloud platform. You can use anywhere with the help of cloud, Gmail or Google Drive account. But notebook you are using means it is an offline tool, but you can run in your laptop installing Anaconda Python, Anaconda Navigator in your in your PC or laptop. Then offline it is working. But in cloud environment, Google Colab is best one. But my choice is you are going for big project in single project using more safe. You using Google Colab in your laptop. Otherwise, you are using small data set, 1 GB or 2 GB, 3 GB data set. You can use Google Colab because in cloud environment you can upload your images. That path is given here. Based on that path from your Gmail, Google Drive, it fetching that data, and data also automatically saved to your Google Drive. So we will move to our project. So it name is called brain tumor detection, brain tumor classification using diffusion UNet backbone. So it is an improved version. I tried many models. Starting time accuracy is very less. Then I improved because the same project I am doing, I am already uploaded in my drive in GitHub and YouTube video already created with a neural network. So in neural network, very good classification possible. Many ResNet good ResNet like good neural network models are available. With the help of that models, we can very tuned brain tumor classification very easily possible. That video I will already uploaded, but this same project I am converted into diffusion models. So in diffusion models, we not getting that much accuracy because diffusion models actual production environment is different. Actually, it is not using for classifying this brain tumor like yes or no condition. It have vast amount of other project exposure is there. It is commonly using for full image video generation or like a 3D image creation, automatic video generation like VO3 or Sora like applications. So that like background, this application diffusion models have more power generating. But in this project, a simple model, I will try how this diffusion model working in brain tumor classification. Okay, we will go through main libraries. So same like other projects, we will using here, PyTorch is using here. You can see that I will zoom my code. So here using libraries are many libraries here I am using. So first one is Torch. PyTorch is using here. Then Torch options, Torch Vision library, Dataset library is using here. Transforming process we will using these libraries. Then import OS, time, random. So mathematical models also using here. So these are the libraries I will import in this project. Next one is define simple UNet backbone. So UNet is very famous, one of the main famous neural network architecture. So here also I am using this UNet as a backbone. It is a partially using UNet architecture for as a classification head. So here class is a simple UNet. You can see that a UNet architecture is using. So simple UNet, one class is defined here, initializing. So down one, you can see that here down one sequential convolution 2D network, it padding is 1, ReLU activation function here using is a ReLU activation function. So you can see that one self dot down 1, self dot down 2 is using here. So what it use is our images are converted into downgrading. Our images are downgrading into low resolution for creating a feature map. So just downgrading our image with the help of this pixel resolution. So down 1, down 2 is using, then with the help of ReLU activation function. Then pooling layer is also there because it is a part of neural network. Max pooling layer is there. So pooling 1, pooling 2 is using here. Pooling self pooling, max pooling 1, max pooling 2. Here also ReLU is using a stride is setting up to 2. So every AI project you can see that the stride is there. So here stride is setting up to 2. So convolution transpose converting these images into based on 128 into 128 stride is 2 like pixels. So convolution transpose converting it into 2D. So up 1, self dot up 1, self dot up 2. So pooling 1 and 2 are doing is it dividing the images into half. So why means it is a downsampling process. Pooling 1, pooling 2, dividing the images into half and downsampling. Then one middle term is here, downsampling. So dividing the images, then converting into middle slice. So we getting more deeper feature in 256 into 128 convolution layer. Then up 1 and up 2 is there, same like it is an upsampling process. Upsampling process objects are up 1 and up 2. So these two are using for upsampling. So first downsampling the images, then again we will opposite upsampling is doing. So these are the steps. The sequential model is using here. Padding is using 256 into 128 image resolution. So upsampling is doing. Then the main area coming here in the diffusion models, forward passing. So here declaring the forward pass, you can see that self dot already created objects, downsampling, pooling 1, pooling 2, then image is sliced into middle part, upsampling, downsampling, upsampling, then up 1 already created. So these are all are combined together in this concatenating U1, D2, dim is 1. So these like we will forward pass is using here. So skip connection is using, we will using skip connection if these downsampling features are combined together and fine tuning with the help of skip connection. The next thing is a diffusion classifier. So we needed one strong classifier for classifying if that image feature how tumor is there or not. So this is the diffusion head using here. class diffusion classifier initializing one diffusion model. So this diffusion classifier module is using at the top layer of UNet architecture. So this UNet architecture top held using as a diffusion classifier. So this diffusion classifier head is using for finding in that image it is there, tumor is there or not, that feature is tried to collect. So one head is using here, same like a sequential model, average pooling is using. So normally every AI project doing that image augmentation process are here also doing flattening the image. Then ReLU is using, dropout is setting to 0.3, linear setting up to linear, sigmoid activation function is using. So every AI projects in machine learning we have commonly using this data augmentation. Here also using same processes, sigmoid function using, ReLU is using, it is converting into sequential pattern pipeline. Okay, flattening the images, dropout is setting 0.3. So these processes are doing here. So what doing is this header is trying to find if in that features any tumor feature is there or non-tumor feature is there in that MRI image. It try to collect and create a feature map. So load pre-trained diffusion models. Next step is so load a pre-trained diffusion backbone. So device is equal to CUDA. We are using working under CUDA architecture. So it is checking any pre-trained diffusion model. If pre-trained layer is there, it is taking the weight from that pre-trained model. If it is not there, pre-trained is not there means it create its own one layer. So that like it working. Yeah? So our model path is saving to this area. One folder is created in Google Drive. So in that area, its name is mentioned as Brain Tumor Diffusion 1.pt. So it extension is we will creating that model extension is .pt. So simple UNet architecture setting to that device. Loading diffusion backbone weight. If it is a pre-trained model means we all knowing that in ResNet like neural network it have pre-trained layer is there. In that pre-trained layer getting means we have a good quality weight is getting. So that weight last layer we will adding our own layer. So based on pre-trained layer features are already set, classification power is there, but we adding our layer to last any last convolution dense layers, then we will getting we merging with the pre-trained layer, we getting an accurate result. So here also same like mechanism is working here. So loaded that one. If already a pre-trained layer is there means it loading. Otherwise one message coming, no pre-trained diffusion weight found using random. So here pre-trained layer is not there means it randomly creating an new weight. So that is else condition telling that print randomly creating, if no weight is found means using randomly creating initialization. Then next we will create the model, build a classification model. Step is a model is equal to diffusion classifier UNet dot to device. So we will create building a new model with this step. So next is improved data pipeline. So we created the model here. This is created the step for creating the model. Next one is we will loading our training directory and testing directory. So train directory means it have a brain tumor detection, one archive path is there. So training path is giving to training directory. So testing images are putting in test1 dot folder. We will check that what inside it is. So go through my drive. So here archive folder is there. Here test1. So test1 inside we can see that two folder is there. Testing folder. If brain tumor is there means yes folder. So some images are I uploaded here. You can see that these all are brain tumor images. In the middle of this spot in the MRI image, you can see that one whitish spot is there. This is brain tumor images. These all images are brain tumor images. Here in right side, one black spot is there. That is a brain tumor spot. Left side, here in top area, one brain tumor section is identifying. So these all images are we will upload as a training set. Next we will checking that what is in no folder. So in the no folder, these are no brain tumor images. So you can see that there is no any spot is recognized in this image. Here these images are healthy brain images. Here there is no spot we will notice as a symptom of brain tumor. So this is also we will uploading as a training data set. So this model finding that no image is giving a tumor image is giving a. So tumor image have some spot is there. Based on that spot, that model, that feature is extracting and recognized that these all images have small brain tumor like spot is there. That is a deviation. That is a classification difference is there from the healthy image. So that like that model is trained and finding that classification difference between these two. So testing also same like images are there. After model created, we will testing from untouched images. So here in testing images also many images are there. In this testing folder both is there. Some are, these all are non-brain tumor images. So many images are there. Here this is brain tumor is there. So we will checking that it is working fine or not. These images are brain tumor images. So these are correctly predicting means our model is working fine. Okay, so we will uploading our training directory, testing directory. Then also same process is again repeating, transforming resizes into 128 into 128. Horizontal flipping is doing here. So whatever we have doing in initial stage, same process, one image uploading time also we will again doing needed. So brightness is setting here. It is transformed to tensor. So it is working on tensor also. So tensor model also setting to tensor. Normalize the model. It a mean and the standard deviation also putting here. So mean standard deviation things also finding here. Then training data, testing data, path is fixing here. So dataset dot image folder. It is the training dataset, testing dataset path is giving here. So if there is any imbalance weight is there, some example like in training data set 100 images are there and testing data set images are in training data set yes folder 50 images, no folder 20 images means it is imbalanced. So that like condition, we can write code for balancing the image using weight random sample. So this weight random sample is using for arranging or balancing our weight. So it automatically balancing the weight of our input folder images. So training loader, testing loader, training starting one message coming training samples. So the same like a testing samples, one print message is coming. How many classes are there? Here two classes only, yes or no. So that classes a train data dot classes means our two classes as yes and no. Two classes are displaying here. Then training setup. So here training setup, one loss function is using here. So BCEL loss means it full form is binary cross entropy loss. So we will finding tumor or not using which binary cross entropy. BCE loss is finding here, binary cross entropy loss. Based on this entropy, we will finding the percentage of accuracy in that image. If it is below 0.5 means it is tumor, above means non-tumor. So that like we can setting possible. Then epoch is using 25 iteration is using here. Then training starting. So here also after training epoch is running, total loss is calculating here. Here using optimizer is Adam optimizer is using here. Epoch 25 round epoch is working. Then training loop means so here you can see that epoch images are uploading, training loading, image label creating, image plus 0.2. So noise we will adding here, randomly adding each image 0.2 percentage. Noise is adding to each iteration. So first 0.2 again 0.2. So more noise adding and that full image is converting into a noisy image. That step is going on here. So each epoch average loss we will printing here. Each epoch we will printing the average loss. So average loss is a total loss by length train folder. So it is finding here. Then print training finished. That message is coming. After training finished, save that model. So model is saving into your Google Drive. So torch.save model.state save path. So our model is saved. Then evaluation on test set. So after model creating, we will evaluating based on test folder. So model.evaluate. One gradient is calculating here. So based on gradient, we will checking a prediction score. So prediction score is predicted is equal to predictor greater than 0.5 means tumor. Our values, total values predicted is 0.5 above means it is a tumor image. If below means a non-tumor image. So that step is writing here. Print test accuracy. Total accuracy is printing here based on test accuracy. After that, we will checking a single image giving and testing that it working fine or not. So predict single image class is a non-tumor or tumor image. Image path is giving you can see that testing from testing no folder subfolder 1.jpg. So you have already recognized that this is a non-tumor image because it is coming from no folder. Okay. Then that image is converting into RGB, transformation is doing here, gradient probability calculating, checking that it is 0 point above or 0 point below. So this program is running. So epoch is running here. you can see that the total epoch is 25. So epoch 1 starting time loss function is 0.69. So every iteration weight are changing. So small changes come in that loss function. So different epoch loss function also small deviation coming starting 60.69, then dot 59, 58, 60. So average is calculating total epoch training finished. So that model is saved. So full epoch running training finished model saved to this path .pt diffusion classifier 1.pt. Our accuracy getting is 65.28. So that image is 65.2. So one first image predicted correctly. It getting value is 0.23. It is below 0.5, so that it is a non-tumor image. So we correctly identified. So noise adding, full noise happening in forward process, reverse also doing from the full noise image. We will recollecting the features of brain tumor is there or not. Last many iterations, a pure image is getting, that is diffusion process. In that pure image, we have correctly recognized that features, it is tumor is there or not. This is a working mechanism of diffusion models. So we correctly predicted that one JPG image have no tumor. So this like it is working. So here only I am checking one single image only checking here, but you can give one folder full images also. So here I uploaded one folder path is giving here. Here no folder full path is giving. Then that full images are correctly telling if it is non-tumor or tumor. Okay. So that is also we will possible. One time created this model, then again this epoch running process not needed because we will already save this model. Just to load that model. After that training testing image path given enough. So one folder we have 100 images are there. Just to give that folder path as an input. One by one image is taken and it given to that already loaded or saved model. Based on that model, it one by one predicting it is brain tumor is there or not. So here you can see that I will created after that same process. I loaded that model. Our model is already saved here. Just loading that model, successfully model loaded, then testing that model, testing full folder is giving a. Then here I calculate one matrix. Okay, so this matrix confusion matrix is creating here. So in this matrix and classification report also I will created. In this report you can see that accuracy, precision, recall, F1 score, everything equation is correctly given. Then matrix values, Y true, Y prediction, recall, precision score. This calculation matrix and classification report are commonly using for using for predicting or checking our model's accuracy, how much properly it working based on true positive or true negative, how many values correctly predicted, how many values wrongly predicted in testing case and training case. That like full details we can get with the help of confusion matrix or this classification report. So that is also created here. You can see that precision, recall, F1 score, that details are there. Accuracy is 62 percentage. Accuracy, precision, recall. So that brain tumor classification matrix also created. So in this model, accuracy is actually less. We have using the same project already uploaded in with the help of ResNet. That accuracy is 98 percentage.
because these like classifications, ResNet like a classifier is very best for performing. But in this project, I tried how diffusion models working. Actually, diffusion models application is not this like a binary classification. It application is entirely different. So that here this classification result is comparatively ResNet here 62 or 70 only. Okay, why means this like a simple brain tumor classification best method is ResNet or EfficientNet or simple classifier is enough. But here I am trying how diffusion models are possible for doing these tasks. So just checking only. So here 25 is correctly predicted. Here 20 also correctly that yes or no condition getting. So that full images are given here. So precision is here improved 81, recall 61, F1 score is 70. So you can see that better result is getting here. So that model, one chart also I will prepare, some bar chart is I will prepare here. So this like a result needed for our project result. We needed confusion matrix, classification report, this F1 score, precision result. These all things are helping for a person can check that your model is fine or not. Everything is 90% result getting means this bar chart or this report confusion matrix we can identify every element about your project, it is working fine or not. So this bar chart also predicting the accuracy, precision, recall and F1 score. So these like things are the result of all machine learning projects we have commonly using these like bar chart, pie chart, then confusion matrix as a result. So here one ROC curve also checking here. This ROC curve also our projects almost working fine because its accuracy is 65 only. So that like a performance in this blue line it giving. So it is narrowly increasing. Then it reaching the top area. So this true positive rate and the false positive rate is comparatively better result is giving because of the 65% result. If it is 90 means very accurate graph is given here. So this type of curve also, this like ROC curve result also every AI project you can do, you can attach in your report. Report these things are main thing. So, so this is an example of diffusion models. So this is a new technology. Diffusion models also different types of diffusion models are available. So nowadays Sora like video editing apps, VO3 like a big companies producing AI models backbone is actually diffusion model. It is a very complex technology actually, but big companies investing lot of money for this development and they will create much better AI video editing models. So this is a simple model I will try for how to use diffusion models in a simple AI project. So I think you understand this concept. So I will upload this code in my GitHub and Kaggle. You can download and you can try this one. You can try different diffusion models also and telling me in comments how it is performing. DDPM like different models are available. So different models giving better result I think. So you try the different models with your different AI projects, then tell me in my comment box it working fine or not. For more AI related new technologies, new relevant things, many projects I already uploaded in my YouTube channel. You can follow me, subscribe my channel, and follow in GitHub also. Thank you so much. Signing off, Sanju Anand.